Okay, so this is where we left off in the previous video, and I said I was going to talk about these jagged arrays. So um, what we talked about before was sort of like a full-fledged, well, I called it a full-fledged 2D array. It's because how much memory, it's 2D, it has a certain number of rows and a certain number of columns, and there's a memory allocated for every single one of those slots. But sometimes, and actually I don't know how common this is, but sometimes you might want to have a two-dimensional array that doesn't really have the same number of bytes allocated in each row. Maybe some rows are big, some rows are small, like this, and that's what we call a jagged array, and you can see why, right? So here's how you define a jagged array. Let me come down a little bit, get rid of that junk. So a jagged array in C is just an array of pointers. And so um, I don't know if you can see up here, I've defined some arrays. So here are three arrays, and they are arrays, right? These are constant character arrays. And so this thing is an array. It's a sort of an array of arrays because it's an array of char pointers. And char pointers, we've been over many times. It takes a long time to get used to, but we have been over many times how a pointer sort of is an array. So this is like an array of arrays. But because each row has its memory allocated independently of the other rows, they don't all need to have the same length. And in fact, in this case, they don't. So there's going to be, the system is going to allocate, I presume, just enough memory here to store this constant string and so forth for the other ones. So when we get down here, we can, let me, maybe I should finish this. Anyway, I started the print function down before, but I'm just going to print out, how do you print out a couple values? Let's do that. So let's print out, they're going to be characters, I guess. And so Jagged, keep thinking of Alanis Morissette. And also the old 97s have a nice song with Jagged in the title. So what should we do? What I want to show you is that you still use the subscript notation just pretty much the same way as before. So if we do this, now we're talking about the second line, which will be the final frontier. So let's try to get this H printed out. So that'll be trust what I write, not what I say. So this is the one, H should be 1, 1. And if it's not, this video is going to abruptly end because I'm just going to kill myself. And let's erase this. Right. So you still use the double subscript notation for jagged arrays just like you do for the full 2D arrays. And of course you can, if you want to malloc these things manually, you can do that. So that's 1 byte. So that's 1 char for the first row, and then 2 chars for the second row, and then 3 chars for the third row. The machine is going to give you nothing but praise for doing that. And so there's a non-printable ASCII character, I guess, there. When you do malloc, you just get junk, so that's not too surprising. And okay, so now the question is, what's the syntax for passing a jagged array to a function, something that you will probably need to do if you use jagged arrays. So let's try to get that working. Jagged 2D. And right now it should blow up, and nobody could fault it for complaining, right? And if we actually run it, get that out of the way. It's not blowing up, so that's progress. But is it even compiling? Yeah, it's compiling, and it's printing out 2 is 0. So it's not giving me a seg fault, but that doesn't mean that it never will give me a seg fault. Sometimes if you run off the end of an array or try to modify memory that you don't own, sometimes it blows up, sometimes it doesn't blow up. But you shouldn't ignore this warning. So I think what to do in this case is pretty obvious. Well, for one thing, this is a mismatch. What if you just do it like this? Does it like that? Let's just try several of the plausible things. Here you actually get an error. And I will stop screwing around because I don't want to give the impression that I don't know what to do. So that's the right thing. And it's just like this. So we've already seen that. We've been working with this jagged array, which is, the argument vector. I've seen it many times. And I believe that's all there is to say about jagged arrays, and I will stop this and make another video on dynamic arrays. And so, we're getting more and more free, right? So now the number of rows is fixed. Initially, when we did the full 2D array, the number of rows and the number of columns was hard-coded. Now only the number of rows is hard-coded. Now we're going to get down here to dynamic arrays, and neither one is going to be hard-coded. So this will be the most free of all. Oh, there is one more thing to say, is if you want to give back this memory, you just need to do it line by line, right? So you would do free D0, free D1, free D2, where D is the name of the thing. You probably already, are you still here? It's over, go home. And let me just show you how much it likes that. I forgot a semicolon on line 29, right there. So that gives back the dynamically allocated memory for the column space.